Welcome to class 6 of computer network basics. In the last class we have discussed about how to connect two PCs and we verified the connectivity using the ping command. In this class we will discuss about another protocol, which is address resolution protocol. So in previous class we have done this lab, right? So PC1 has an IP of 10.0.0.1/24 and PC2 has 10.0.0.2/24. When we issued on PC1 the command ping 10.0.0.2. So in the last lesson we have seen that PC1 needs to send a packet to PC2 when we issue this command. In order to send that, it needs to include from and to address details on that packet. So from address, it will put its own address. So from the configuration, PC can find what is the IP address configured by the administrator. So it will include that here field. For the MAC address, it will check its own network interface card MAC address and will update this field with its own MAC address. In to address, as we have given in the ping command, we have provided the IP where we want to PC1 to send a packet. So from this, it will update the value here as 10.0.0.2. Okay, so next here we should put MAC address of PC2. So how does PC1 know the MAC address of network interface card of PC2? Okay, for suppose if you want to send a letter to someone, you will ask the person about their address, right? But in this computer networks, it will use a protocol for that, ARP, address resolution protocol. Okay, let's see how it works. So when a machine doesn't know MAC address of another machine in the same network, the keyword here is in the same network. So when a machine wants to find out another machine MAC address, it will use this protocol. So in ARP there are two packets, one is request, another one is reply. So ARP request packet looks like this. So inside data, so this is the ARP request. So inside it is asking who has 10.0.0.2, tell their MAC address to 10.0.0.1. That's the message inside the packet. So where we need to send the packet. So from address we put the PC1 MAC address because this is the one sending the ARP request. But to address we don't know, right? So that's why we are sending this, PC1 is sending this ARP request. So it will use a special MAC address in the to, which is all Fs. So in previous classes we learned the MAC address format, right? It's hexadecimal, means 0 to 9 and A to F. So this will be the last address in the MAC address format. So what does this mean is, it is a broadcast. We also learned the different types of communication: unicast, broadcast and multicast, right? Unicast is one to one, multicast is one to many, broadcast is one to everyone, one to all. So this is the example of ARP request is a broadcast traffic. That means whenever a packet has a destination MAC address like this, it is intended to go to all the machines in the same network. In this topology you can only see two machines, right? But even if you have 100 machines in the same network, the packet will go to all the machines. Okay, so that is the special purpose of all Fs using in the destination MAC address. And also you can see there is no IP address. Okay, so here it is only using the MAC address to send the packet. Okay, so once this goes out from PC1, it will go to all the PCs. Okay, but in this topology the packet will go to other end of the PC2. Okay, once it goes to PC2, PC2 will check the packet, and inside that the request is who has 10002, right? So it will check if it is its own IP address or not. In this case it's this own IP address. So then what it will do is it will construct another packet and will reply back with okay, yes, I have 10002, and it will include its own MAC address. Okay, so this will be the ARP reply data. This is ARP reply. Okay, so there is no IP address in the ARP reply, and from address is PC2. Now PC2 is sending this packet. To address is PC1 MAC. So how does PC2 know about PC1 MAC address? So it will get it from the ARP request. In the ARP request previously we have seen PC1 including that information, right? It says like my IP is 10001, my MAC address is PC1 MAC, and my target which I want to know is 10002. So that's the subject in the ARP request. So that's where it got this information. Now it will reply back to the PC1. If you see, this is unicast because this packet is indented to only PC2, not for everyone. Okay, so ARP request is a broadcast. Request will go from one PC to all the PCs. So this is broadcast. ARP reply, only the machine which has this IP will reply back. For suppose in this case, if we change the IP of the PC2 to 10003, it won't respond for this ARP request because it does not have that IP. It will simply drop that packet. It won't reply. Only the machine which has the IP address matching, that will only reply back, and it's when replying back it will only reply to the machine whoever sent the packet, right? So ARP reply is just one PC to another PC, so this will be unicast, and there is no IP address involved in the ARP. Okay, so here we can see, so first after establishing this lab, I entered the command show ARP. What this will do is it will show if this PC has learned any IP to MAC address mappings through that process. So in this case it is empty, this table. So then I issued the ping command. So before the PC1 send this ping packet, in order to send this packet it needs to know the MAC address of 10002, right? So in the background the PC1 will send the ARP request. Once it receives the ARP reply, then only it will be able to construct the packet and send it out. Otherwise it won't send. Okay, so this happened in the background. Then PC1 got the MAC address of 10002 and sent 5 ping packets, and all of them are successful. Now I have issued the show ARP command. Now you can see 10002 having this MAC address. So whatever the NIC has, network interface card has this IP, it responded for the ARP request with its own MAC address. So PC1 updated its ARP table. So when you try to do again another ping command, PC1 won't try to do another ARP request because this entry is already in the ARP table. So it will just take it from here. Okay, but this value expires in 130 seconds in this particular machine. So every machine keeps this information for some time only. It's not like permanent entry, because you can change the IP of PC2 to .3 something, right? Or you can move this IP to a different machine. So these ARP table will have some time value. So it will depend on the type of device. Okay. So when we go to PC2 and when we do show ARP, even though we didn't initiate any ping request from PC2, it learned about the 10001 MAC address. How it is learned is, whenever it received the ARP request, from that it was able to identify where this IP address is, and it's updated its own ARP entry. Okay. So now if you try to ping from PC2 to PC1, it won't send ARP request because it already knows about the PC1 MAC address. So let's look how it will look it in the Wireshark. So as you can see, there is only Ethernet header, means which is only has the source MAC address and destination MAC address. So by looking at the destination MAC address all Fs, I know that this will be the ARP request. So this is the broadcast address. Wireshark is interpreting this MAC address as broadcast, means it will go to every machine in that network. So from here we can tell this broadcast is ARP request. Okay, so let's see what data it has inside it. So it is including 4 fields: sender MAC address and IP address, target MAC address and IP address. Sender will be whoever is sending this ARP request. So the machine with IP of 100.193, its own MAC address. Okay, so this is the machine sending the ARP request, and it is looking for 10.0.0.5.15 MAC address, target IP address, and target MAC address it does not know, so that's why it is sending this request, right? So it has all zeros. So once this request goes to the target machine, only the machine which has this IP will reply back. Now let's see. So this is the ARP reply. So now you can see source has specific MAC address, destination has specific MAC address. So this is unicast, and from this we can tell it's ARP reply. Let's look what ARP reply has. So now it has the same 4 fields, but the values now different. Sender MAC address is whoever has sending this ARP reply. Target will be where it is sending. So inside this, if you see, it is replying back with its own MAC address. That's how when PC1 sent ARP request to PC2, PC2 replied back with this address. Okay. So how PC2 learned about the PC1 MAC address? Because in the ARP request, PC1 will be already including its own MAC address in the sender. So that's where it took the MAC address for that particular PC1 IP. Okay. So assignment for this lab is to build similar topology. You can use any IP address scheme, but just make sure they are in the same network, and use show ARP command to verify the ARP entries. And you can install Wireshark on your PC and capture the ARP traffic. How do you capture the ARP traffic is, you just apply the filter ARP on the search bar, okay, on the filter section on the Wireshark. So how system will generate ARP traffic? Only when it is trying to find out MAC address of a machine in its own network. So for suppose if your machine has this IP, so you can try to ping all the IPs in that network. For suppose let's start with 10.0.0.1. So usually the first IP address or the last IP address will be your gateway. We will learn about that in future. But you can start pinging all the IPs. Only if some IPs will respond, because in your network you might not have all the 254 devices in this. Okay. So some pings won't work, but the system, in order to send, for suppose there is no machine in your network with the IP of 45. So when you do the ping command, your system will generate ARP request first, because it wants to know the MAC address of this IP in order to send the ping packet. So if there is no machine with this IP, in the Wireshark you only see ARP request. you won't see ARP reply. Okay, because there is no machine which has this IP. So another way you can capture the ARP replay. To capture the ARP replay, what you can do is from your command prompt you can delete the ARP entry table. So normally the command will be ARP space -d. So what this will do is it will delete the ARP table. Okay, so once it is deleted, you should be able to see the system is sending ARP request for the any outgoing packets. Okay, then you will be able to see the ARP reply in the Wireshark as well. So that's all for this class. We'll meet you in the next class.